Pharmacologists have shown that the rate at which penicillin leaves a person's bloodstream is proportional to the amount of penicillin present. So that is my key word, that the penicillin is proportional to the amount of the penicillin present. So part A says express this statement as a differential equation. So that's the same thing as the rate of change of the penicillin is equal to a constant which is proportional to the amount present of penicillin. So P is the penicillin, K your constant, T is your time. Part B says find the decay constant. In order to find the decay constant, I need to solve this differential equation. And we know what the solution to that differential equation, it would be P equals P sub 0 e to the kt, where P is the amount of penicillin present, P sub 0 is the initial amount of penicillin given, K is your constant, your decay constant, T is time. So we're trying to find the decay constant K if we know that 50 milligrams of penicillin remain in the bloodstream 7 hours later, and you have an initial injection of 450 milligrams. So P sub 0 is going to be 450, and P equals 50 when T equals 7. So I'm going to substitute all that into my equation to find K. So I'm going to divide by 450, take the ln of both sides, and K ends up being negative 0.3138. One of the things that you need to be careful with these word problems is on your calculator, I saved this under A because you can't cut it off, because then you're going to get an error and you might get a different answer as me. So I did write it to 4 decimal places, but on my calculator I stored it because we're going to need this for part C. Part C says under the hypothesis of B, at what time was 20 milligrams of penicillin present? So we're going to use that equation given with our new decay constant. And notice, once again, I'm only using negative 0.313, but in my calculator, I have it stored as the whole thing under A. So I know that I want to know the time when 200 milligrams is present. So I'm going to substitute that into my equation. I'm going to divide by 450. And my times ends up being about 2.583 hours. Now, if your answer turns out to be a little bit different than mine, that's because 1, you didn't use all your numbers in your calculator, and even though this is 0.44, I'm using all the numbers on the calculator. Same thing with this one, negative 0.81, I'm using all the numbers on the calculator. So I get about 2.583 hours.